Hello, my name is Margaret. This is Public Health Engineering Lab that is in Civil Engineering Department. Today we are going to conduct determination of iron in a water sample. This is our water sample. We are going to use a calorimetric analytical method by use of a Lovey bond. So this is the Lovey bond comparator, and this is the disc that we are going to use. The disc number is 3/11. The apparatus that we are going to use, these are the separating funnels. This is the rack. Then these are the reagents that we are going to use. One is dilute HCl, dilute hydrochloric acid, potassium permanganate, ammonium thiocyanate, and amyl acetate, amyl alcohol. These are the pipettes and then the test tubes that we are going to put our sample. So with this method, the color standards are designed on this disc. They are designed to match the red color that is produced when ferric ion reacts with ammonium thiocyanate. So we'll use the red color. So the first step that we do, we normally you are supposed to take 5 ml of the sample into the separating funnel. So we start by doing the procedure. So we'll take 5 ml of the sample into the separating funnel. Then we are going to take 1 ml of dilute HCl. Then 2 drops of potassium permanganate. Then we mix. Then the next step is 5 ml of ammonium thiocyanate. Then 10 ml of amyl alcohol acetate. Then we are supposed to thoroughly mix the content. After that, 2 layers will form. So we are supposed to discard the lower part and remain with this upper part, which has the ion concentration. So with the help of the amyl acetate alcohol, it helps us to extract the ion that is in our sample, so that now we only get the ion concentration. So after that, we are supposed to discard the lower part. So after extracting the ion, now we put it in a test tube. So we are supposed to put our sample on the right-hand compartment of the Lovibond disc. Again, we are supposed to repeat the same process now by use of a distilled water. So we'll use now 5 ml of distilled. We'll take 5 ml of distilled water. Five ml of distilled water. One ml of HCl. 2 drops of potassium permanganate. Then we mix. Then we add 5 ml of ammonium thiocyanate. And then 10 ml of amyl alcohol acetate. Then we thoroughly mix the content. Then now we separate. We discard the lower part. We'll remain with the upper part. The distilled water, we put it on the left-hand side compartment. Then now from a source of light, we are supposed to rotate the disc. And where the 2 circles matches, we take that reading. Yeah. So after you take the reading from the disc, we are supposed to multiply by a factor of 200 now to get the ion concentration according to the procedure. So it will be, our reading is at 0.002 times 200, it will be 0.4 milligrams per liter. So our ion concentration in this water sample is 0.4 milligrams per liter. Yeah, so after getting the results of the ion concentration, you can go to the NEMA standards of WHO, depending on the purpose of their water, to check what is the maximum permissible level of ion concentration in a water sample. For instance, for drinking water, it's 0.3 milligrams per liter. So for this, it's slightly high than the permissible level, because the permissible level for drinking water is 0.3 milligrams per liter. But for our water sample, it's 0.4. Yeah, so it's not fit for drinking or domestic use.